Oh, yes. So it's still chapter 6. Yes, let me go back. Yes, 412. Yes. So today is the 2nd, right?
Yes.
And you said problem 81.
81.
Sorry. 81. X to the 4th. Very good pick. Minus 14x squared minus 32. So this is problem 81 on page 412. And I look at this and I realize that it's exactly the same type in which I see an x squared and I see an x to the 4th. So the cubed is missing, the term with the 3rd degree and the term with the 1st degree is missing. So then I'll say, oh, okay. So if I denote this by t, then this must be
T squared.
right. Because if I square x squared, I get x to the 4th. That's the only reason. So t squared minus 14t minus 32. So this is a quadratic polynomial now. It wasn't before. It was 4th degree. But since this polynomial is quadratic in form, I am allowed to do this. Actually, I'm allowed to do it because it's a tool, right? It enables me to easier factor the given polynomial. So it's like something we invented together. This is what we want to do because it will be easier to solve. And now I see here that I have to find that so it's a polynomial. Now it's a trinomial, descending order, yes. Greatest common factor, no. Negative leading coefficient, no. Special product, no. But at least one is the leading coefficient. Since the product is negative 32, and the sum is
Negative 13.
very good. Since the product is negative, I'm expecting
Negative 11.
very good. And since the sum is negative 14, I know exactly what I need. Okay, let's say that 32 is a big number. Divisible by 2, yes. 16. Divisible by 2, yes. 8. And 2. And 2. I meant to write 4. And 2 and 2. 1, 2, 3, 4, 5. So 32 is 2 times 2 times 2 times 2 times 2. Of course it will be negative. So from here I need two numbers whose product will be the whole thing, but whose sum will be negative 14. Let's try and group them. I need two numbers that will include everything. And one will be negative and one will be positive. Any ideas? Right?
Yeah, negative 16.
Very good. So I have x minus 16 and x plus 2. Sorry. Good. So now I have to go back. Back where?
To the original equation.
Right, which, yes. So how will I continue then?
So I have to substitute x squared back in for t. So
Exactly.
X squared minus 16.
Excellent.
X squared plus 2.
Exactly. Can any of these two be further factorable? Can any of these two be further factored?
Yeah, the first one.
Very good. How do I factor x squared minus 16?
X minus 4x plus 4.
Very good question. Thank you. Anything else? Anything else you worked on? Anything else you'd like to ask? just opening my one more account so I can upload the file if I need it. So it's open already. Okay, very good. So do we need to go back to any of what we just discussed? Factoring or, yes, actually yes, two. We have two things to solve. We have b squared minus b plus 1 equals 0. And then I have to talk about the discriminant, which is b squared minus 4ac. Okay, good. So this is not factorable. Do not attempt to complete the square or do any of that. What is the best choice here out of all those four methods? If it's not factorable and I don't want to complete the square because I don't want to have to eventually take the square root. I mean, it's fine, but then I will work too hard. Exactly. So then I have b equals, now be very careful, the variable is b and we're thinking of b. So b is the leading coefficient, b is the coefficient of b, this one, -1, and then a is 1, and then c is 1. Careful. So negative b, 1, plus or minus the square root of b squared minus 4 times a times c times 1 divided by 2a. So then this is 1 plus or minus the square root of -3 divided by 2. But what does the square root of -3 mean? We discussed this in chapter 10.
That's the complex numbers.
Yes. So this is 1 plus or minus. Excellent. And that's it. We couldn't do this last time before studying 11.2 because we did not know at that time the quadratic formula. Now I would like to go back and discuss the discriminant for a second. B squared minus 4ac. We know that a, b, and c are what type of numbers?
Real numbers.
Exactly. Right. So now here I see I square a real number. Here I multiply two real numbers. I multiply by -4 and I add, subtract, whatever. So what kind of number can this be? When I add, subtract, multiply, square real numbers, what will I get? Okay, very good. So it could be positive. It could be negative. What other possibility is there? A number that is not positive and it's not negative. Correct. So these are the only three possibilities for any real number. It can be positive, negative, or 0. So now let's go back to the quadratic formula and discuss what happens in all these three situations. So here's the quadratic formula. Right? And this is the quantity in question, this one, under the square root. So can you please tell me what happens if the discriminant of a quadratic equation is positive? So I'm telling you now, this quantity, let's say, is 4. How many solutions will the equation have? It will be negative b plus 2 over 2a. It will be negative b minus 2 over 2a. So how many solutions? 2. And they are real numbers, correct? 2 real solutions. I would like to insert a word in here, distinct. They're not the same, distinct. One is 5 and one is -3, as an example. Good. What happens when this quantity is all 0? In other words, I'm telling you this disappears because it's 0. How many solutions are there? 1. However, there are 2, but the same solution. So we will write one real solution, but we know this is a quadratic equation. The degree is 2. I have to write 2 solutions. Okay. And now the third possibility. Assume like we just had We had the discriminant. What was the discriminant on the previous equation that we just solved? Correct. So then that's another possibility when the discriminant is a number less than 0. What happens then? Look at those solutions that we got from that solutions of that equation. What type of solutions are they? Say it again.
Complex.
Yes, or imaginary. Very good. They're not real. These are not real numbers. So when the discriminant is less than 0, the equation has two imaginary. It's correct if you want to say complex. I agree with both solutions. We say imaginary because if we say complex, we have to say two complex numbers. But if I say imaginary, I can say solutions. It doesn't matter, really. I'm fine with both. Good. I like to work on a problem like this, in which we are asked, we are on page 669. And let's say we work on problem 44 on page 669. We are given 9x squared plus 1 equals 6x. We are not asked to solve the equation. We are asked to use the discriminant only to determine the number and types of solutions. Number and types of solutions. What do I have to do first? Exactly, because I cannot identify correctly A, B, and C. That's the very first step, and I have to arrange it in descending order. Thank you. 9x squared minus 6x plus 1 equals 0. Now I know that A equals, yes, B equals perfect, and C equals 1. All I have to do is determine the discriminant first. Remember, B squared can never start with a negative number. Even if B is a negative number, I have to square that. So B squared equals how much? Very good. Minus 4 times A, which is 9, times C, which is 1. What is the answer? Four times 9, not 3 times 9.
36.
Very good. Which is?
0.
Good. What do we conclude about this equation? Although we did not determine the solutions, we can draw a conclusion. What is the conclusion? It will have, or it has,
One solution.
one solution. Only one real solution. And to be exact, I should write in parentheses, it's the same solution twice. That's the correct answer. Good. Let's look at a word problem here. Okay, 58 on page 670. A rectangle is 3 times longer than it is wide. Here's a rectangle. Here's the length. Here's the width. And I'm told a rectangle is 3 times longer than it is wide. What equation do I have to write immediately? But if I write 3x equals y, it means that the width is 3 times x. But the length is longer, right?
Right, so x equals 3y.
I completely agree. Is that clear?
Yes.
Okay, perfect. It has a diagonal of length 50 centimeters. So I have to draw the diagonal. It doesn't matter which side, but this is 50 centimeters. Part A. Find the dimensions of the rectangle. What do I have to write? There is something that we know and we applied it in chapter 10. We also had a little question on the test. A rectangle has 90-degree angles here. So this is also y. And this is what type of triangle? Good. So can you give me the Pythagorean theorem for this triangle? It's the sum of the squares of the legs equals the hypotenuse squared. The longest side squared equals the sum of the legs squared. So what do I write here? Perfect. What do I write here? Yes, but I will write 3y. Perfect. What do I write here? Indeed. So let's solve this equation for what? What are we solving for? So let's solve the equation for what? How much is 3y? Everything squared. 9. Good. Plus y squared equals 50 squared is 25 and 2 zeros. The left-hand side. Very good. Remember the two key words, factor, simplify. What will I do now? I have to. Absolutely. Very good. We divide both sides by 10. So then I have y squared equals 250. Which of those four methods is applicable here? Very convenient method right now. Take the square root. Very good. Since it's quadratic, how many solutions will I get? The degree is 2. 2. So how do I get them? Because if I forget this, I make... Exactly. And remember, 250 is 25 times 10. So this is 5 times the square root of 10. However, since we are talking about dimensions of a rectangle, I will leave it as is, but I will say only y equals 5 the square root of 10 centimeters. So I show my professor that I know what happens when I take square roots, and also I show that I know that this is a distance and it cannot be negative. Good. But we only determined y. We are asked to find both dimensions, of course. So I go back here, and I see that x equals 3y. So then how much is x? Excellent. Centimeters. And there is a part B. Find the perimeter of the rectangle. How do I find the perimeter of a rectangle? What is the formula? Of course. Good. So 2 times x. X is right here. How much is 2 times x? Excellent. Plus 2 times y. Y is right here. Are they like radicals? Because if they're not, I have to leave them alone. But if they are like radicals, then I have to combine. Good. So then 40, the square root of 10 centimeters. Very good. Let's look at one more and then move on. Let's say 88 on page 671. The projected number of Wi-Fi enabled cell phones in the United States can be modeled by a quadratic function. You have never believed that, right? So negative 0.4 x squared plus 21x plus 35. And this is the source, so this is real. So they took a lot of time to collect data and fit this model, a quadratic function, through the data that they collected. Okay, very good, well done. Where C of x is the projected number of Wi-Fi enabled cell phones in millions, and x is the number of years after 2009. X, number of years after 2009, which means 2009 represents x equals. Thank you very much. Part A. Find the number of Wi-Fi enabled cell phones in the United States in 2010. How much is x for 2010? 1. So what do I have to find? C of? Perfect. So that will be negative 0.4 plus 21 plus 35. I would like to show you how to put this in the graphing calculator. So if you don't have your calculator, you can use mine. So in y equals, in the graphing calculator, right here, y equals is right here under the first tab under the viewing window. In y equals, type in negative 0.4, negative 0.4. Here's x. This key right here under mode, that's where the variable is, x. Here's the power 2 right here where it says x squared. And then minus, no, I'm sorry, plus 21x. And plus 35. Once you have the function in y1, let's do the next step, this. Second and table set. Table set is the second tab, second button from left to right, under the viewing window right here. Second and table set. Make sure that the independent variable is in the ask mode. So scroll down to the right and highlight ask only for the independent variable and press enter. So it looks like mine. Now you can go back to second and table. Table is the last. Second and table, the last button under the viewing window. What do I want to evaluate this function for? 1. So press 1 and enter. So it's 55.6. What is the measurement unit? Million. 55.6 million. Part B. Find the estimated number of Wi-Fi enabled cell phones in the United States in 2012. What does X mean? Yes. Of course I should write years for both. Good. So go back to your calculator. What do I plug in now? 3 and enter. 94.4 million. So C of 3, 94.4 million. Okay, part C. If the trend described by this model continues, find the year in which the projected number of Wi-Fi enabled cell phones in the United States reaches 150 million. Now, what is the question asking us to do? Exactly. Exactly. So then 150 equals what? That's my y. So y is given now, it's 150. And I have to replace it in the equation because c of x or y, they mean the same thing, correct? So then I will have to, of course, the only method that I will ever think of in this case is of course, let's move everything to one side. 0.4x squared minus 21x minus 35 and plus 150 equals 0. So, say it again. When I move this to this side, it becomes positive. When I move this to this side, it becomes negative. That's okay. Oh, because I did that because I want always a positive. Yes. But it's okay if you do it the other way, but then you will have to multiply both sides by -1, which is the same thing. It will give you the same answer. So 0.4x squared minus 21x, and then plus 115, is it, equals 0. How much is A? How much is B? How much is C? Good. Let's put this together in the graphing calculator, but let's write it first. It's easier to copy it. So then x equals negative B. Careful. Very good. Plus or minus the square root. Don't perform any calculations. Just write 21 squared minus 4 times A times C times 0.4 times 115. Everything divided by 2 times A, which is 0.8. Tell me if you agree with this. Yes? So 21 plus or minus square root of 21 minus 4AC divided by 2 times A, 2 times 0.4 is 0.8. So now let's do this together. Oh, before I do this, I have to remind you of the following. We will have parentheses around the quantity under the square root. We will have to have parentheses around everything we have in the numerator. Otherwise, the calculator will not perform the calculations as we expect it to perform. Okay, so left parenthesis for the top, 21 plus the square root, parenthesis, with second and quit. Every time you want to get out of something, second and quit is next to it. In parentheses, 21 squared minus 0.4. I'm sorry, I put 0.4 first. I'm sorry. Times 4, doesn't matter. Times 115. Close the parenthesis. Go outside. Close the parenthesis. And divide everything by 0.8. If the denominator were not just one term, I would have put that denominator in parentheses as well. But it only has one term. And then press enter. Now look what I'm doing to calculate the second value. I go back to second and entry. It will copy what I typed in, so I don't have to do it again. And I will override this positive into a what? I will override it by what? Yes, because that's how I obtain two solutions. And press enter. Okay, so I'm going to write x equals 46.29 and x equals 6.21. Do we agree with this? Is this okay? Is this okay? Perfect. Okay, so now let's go back to our problem and make a decision. So we know that in 1 year, we get 55.6 million. In 3 years, we get 94.4 million. Okay? And now, these are years. In 6 years, 0.21, somewhere between the 6th year and the 7th year, we get what? Yes, 150 million. This is a correct answer, but I don't know if in 46 years from now, the model will be still true. So I will disregard. Because it's too far out. It doesn't mean that it's not possible. It means that I don't know if the model 46 years from 2009, because that's 2009 is 0. 46 years from 2009, I don't know if this model is still true. I know it's true for 1 year, 0 years, 2 years, 3 years, maybe 6, maybe not even 10. So both solutions are correct, but I will not guarantee that 46 years from now the model is still true. It was true for 1, 3. I'm assuming it's correct for 6 years, but I wouldn't guarantee that it's correct for 46 years down the road. Okay, now I would like to solve more equations of the kind that Heather just asked. That's section 11.3, nothing else. Okay, so these are solving equations by using quadratic methods. So basically it says quadratic in form. Equations that are not quadratic or may be quadratic, but definitely are quadratic in form. So I'm going to choose a couple. And I'll tell you where they are and feel free to choose. You can choose anything you want from 1 through 58 with some restrictions because we didn't cover chapter 7 yet. So from 1 through 58, and they're all on page 678. Let me choose the first two and then I'll let you choose. We cannot do 7 through 12 because we haven't discussed rational equations. The same thing with 31 and 32 and some others on page 679. So allow me to choose. Okay, one that it's very friendly and you'll have no difficulties with this one. X to the 4th plus 2x squared minus 3 equals 0. That's one. Then I would like to look at 20. And 34. And then we can move on. We'll come back and we'll review more. Okay, so this is a equation. It's not quadratic. It has degree. So we will find how many solutions? 4. Very good. I see that degree 3 is missing and degree 1 is missing. So this is kind of typical for quadratic in form. If I denote this, let's say by A, since Nicole last time said A, then only if this can be replaced by, then I continue. If it cannot be replaced by what you're going to tell me, then I cannot continue. Then it's not quadratic in form. So what could this be? Right, because if I square x squared, I get x to the 4th. We're not making this up. Okay, so now the equation is a squared plus 2a minus 3 equals 0. And I know this is a trinomial. It's in descending order, no greatest common factor, no negative leading coefficient, no special product. But 1 is a leading coefficient, so it gives me hope that I can come up with the factor form right away, which is say it again. Yes, the sum is positive 2. I cannot be negative 3. So positive 3 and negative 1. So then A equals and A equals. Excellent. However, this is not the end. I solved the equation in the letter I wanted. It's a substitution that made me happy. But now I have to go back. So now this equation means what? What equation is this? Exactly. And I have to solve that. Now what equation is this? Right. But they're both nice. Because I have one of those 4 methods. X squared equals negative 3, and then later on x squared equals 1. And I have one of those 4 methods that is, boom, right here. Right, exactly. So this is x equals, and I have to remember what to do with the square root of -3. And how many solutions will this equation have? Right. And how many this one? For a total of? Exactly. So this is? I will not get two solutions if I forget something. Right. Exactly. That's why I said it, in the hope that you will not forget. So now x equals? Right. And we have those 4 solutions. Plus or minus 1 and plus or minus I the square root of 3. Okay, 34. Any questions for me here? Does it make sense? Okay. So this substitution rule is just an enabler. It helps us changing into something that we are familiar with. Because with degree 4, we're not really familiar with. Okay, so 34. 2 quantity 4m, I'm going to change it to x because my m is weird, squared, minus 9, and in parentheses 4x minus 3, and that equals 5. Now let's look at this and draw a conclusion. Do you see anything? By simply looking, don't touch, don't do anything, just look at this equation and say, ah, okay, I figure out a substitution here. What substitution will you use? Which quantity will you substitute for? So we can change this equation into a quadratic equation. Of course. So let's call this t, but only if this, and we cannot fabricate it, it must be there, only if that quantity is exactly what? Which means if this is exactly. Is it?
Yes.
Good. So now the equation is 2t squared minus 9t, and I have to bring the 5, right? Over and 0. Now this is familiar territory. It's quadratic, it's in descending order, no greatest common factor, no negative leading coefficient, no special product. 1 is not the leading coefficient. I'm down to the last chance of factoring it. What does that mean? It means that I have to find 2 numbers whose product is, careful, yes, this has to be incorporated. That's why I said 1 is not the leading coefficient. And the sum is? Perfect. So because the product is negative, 1 must be positive, 1 must be negative. And since the sum is negative, the negative number has more power. Negative 10 and 1. Now what do I do with these numbers? I cannot use them to factor. I can only use them to break that middle term into 2 terms. Break it up into 2 terms. Before we use those numbers, boom, and that was the factor form, but not when I have a leading coefficient of 2. So then this is 2t squared plus minus 5 equals 0. Very good. Since I have 4 terms, don't go back to combine them. That would be terrible. We just worked hard to get those numbers. Not really, but you know what I mean. So now from the first 2, I factor out. Yes. And what is left in parentheses? T minus 5. What should I get from the other 2? Look, if you forget to write the equal symbol and 0, you will not solve for anything. You just change the equation to an expression. Be very careful. So then I need the factor and the sign here. Plus? I didn't hear. Say it again.
0.
I can't. If I put 0 here, 0 times t will be 0. 0 times negative 5. Exactly. So then the common factor is t minus 5, and then I have 2t plus 1. Agreed? And then we have two options for t. What are the options for t here? Careful, it's 2t. I have to move 1 and divide by 2. So 5 and negative 1/2. This would be nice, but it's not done. It's good. I'm closer, but I haven't finished. Now I have to go back to my substitution. All this effort was to find t. But we care about t, nobody else does. So then this equation, which gives us t equals 5, means what exactly? Careful. This is our equation.
4x minus 3.
Correct. 4x minus 3 equals 5. And the other one, t equals negative 1/2, what equation will that be?
4x minus
Right.
3 equals 1/2.
Yes. So now these two equations are what? Type of equations? Linear. And we know we have to separate the terms. So I will move 3 to the other side, and I get 4x equals 8. And then to get x, I have x equals 2. I divide both sides by 4. Excellent. Same thing here. You can eliminate fractions if you want. You can multiply everything by, if you don't want to add or subtract 1/2 from 3. So you have 4x equals 3 minus 1/2. You could have eliminated fractions if you wanted to. So 4x, the least common denominator is, and we have to multiply the top of 3 because it's 3 over 1 by 2. 2 times 3 is 6. 6 minus 1. So then 4x equals 5 over 2. Since I have a fraction on the right-hand side, in order to get rid of 4, I recommend multiplying both sides by 1/4. It will be easier for you to see what you're doing. So 1/4 and 1/4. The left-hand side is x, and the right-hand side is 5 over. Okay, let's look at one more. Like 20. X to 2/3. What is this when I say x to 2/3? What does it represent? Yes, the cube root of x squared. Excellent. Very good. See, we didn't study chapter 10 in vain. Okay, so now let's look at this equation and say it's ugly. And I will have to agree. But using a substitution will make it very pretty. But the question is, with substitution, what will I use? Of course, the one with the smallest power. Guaranteed, always. So if I denote this, let's say by y, it works only if this is, but is it? So let's square on the side. If I square x to 1/3, I copy the base. What happens to the exponents? Exactly. 1 over 3 times 2 over 1 is indeed 2/3. So it's correct. If I denote this by y, I definitely have this one as being y squared. So now the equation is y squared plus 2y plus 1 equals 0. And I know this is a trinomial. It's in descending order. No greatest common factor, no negative leading coefficient, no special product. Special product? I should have asked. Special product. So here's how, let me refresh your memory on how we check. Is this a perfect square? Is this a perfect square? What do I expect? Assuming that this is the right term, what would you expect? Everything? Exactly. So I'm going to write it. And now I check the middle term. We know from our agreement, right, from August. What is the middle term here? times, exactly. Is that correct?
Yes.
Good. So then this equation has two solutions, however, they are both the same. Because it's y plus 1 times y plus 1. So the solution is, you will see how important this is to understand from now what happens with these double solutions. In the next course, you will know what happens. Why? What is it so important to know that there is a double solution in there? So y equals? Good. This is all good, but this is not done. What does this equation really mean? Y equals negative 1.
X to the third equals negative 1.
Excellent. So now I have to think back again and say, oh, x to 1/3 is, and write it. Good. What type of equation is this? Exactly. How do I solve it? The index tells me what to do because I need to get rid of the index or the root. What should I do? Careful. Raise both sides to, exactly. The left-hand side is,
X,
the right-hand side is.
negative 1.
Since I raised both sides to a third power, I know it's going to work, but what does the theory say? Every time I use the principle of powers that raises both sides to a power, what do I have to do for sure? Right. Let's do it. Although we know since it's an odd power, it will work, but I still have to go back and check. Okay. I'm going to rewrite the equation as the cube root of x squared plus 2 times the cube root of x plus 1. And I'm going to plug in negative 1. The reason why I did this is because it's easier. Okay, to see what happens here. When I plug in negative 1 here and I square it, what do I get? Negative 1 squared. 1. The cube root of 1? 1. When I plug in negative 1 here, the cube root of negative 1 is negative 1 times 2. Does it equal 0? This is negative, this is 1, this is negative 2, and this is 1. Does this equal 0? Yes. Good. Okay. Non-linear inequalities. Okay. How many inequalities do we know so far? We know 2. The first one, oh, actually 3. The first one was linear. Let me give you an example. 2x minus 3 less than or equal to 9. This is linear. Then we talked about absolute value. Those two. The absolute value of x minus 1 greater or equal to 3, or the absolute value blah 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 less than or equal to 5. Absolute value inequalities. Then we also looked at compound inequalities. For example, negative 3 less than or equal to x plus 2 less than or equal to 4. And here's the fifth one. Quadratic. And sixth one, polynomial, higher degree than just quadratic. I'm sorry? No, I can count. Sorry, my fault. Okay, so is it clear that we thought in totally different terms in all these three? For the linear, we separated and divided. for the absolute value, we thought in totally different terms, right? Either two inequalities or in between, totally differently than this. Then for the compound, this is similar actually to the other absolute value inequality. But compound inequalities with or and and, right? So that's the category that I was thinking of. So 3 different inequalities, we are thinking in totally different terms. For each and every one, a different procedure. Okay. Of course, this is going to happen here. So you cannot apply what you know from here, here. Like I couldn't apply what I know from here, here, or vice versa. Okay. So let's start with quadratic. And then we'll look at higher degree. On page 687, let's look at number 6. 687. X squared plus 8x plus 15 greater than or equal to 0.